بسم الله الرحمن الرحيم. اللقاء اللي فات احنا حكينا عن the introduction of chapter 11, and this chapter focuses on the investment decision criteria, how we apply different methods or models or tools to estimate whether we accept or reject the net present value. Okay, whether we accept the project or not. Today I'm going to talk about the net present value. Net present value is important to evaluate the project, whether to accept the project or to reject the project. The concept of net present value is built on the cash flow. So it's compared between the cash outflow with the cash inflows, and we know the cash flow is not coming in just only in 1 year or in one period. It's coming in different years and in different periods. The net present value is commonly used by the investors or commonly used by project managers because of the advantages of net present value. One of the main advantage of the net present value is consider the time value of money. This is the importance of this. And the second, it's very simple to calculate the net present value. You can use the scientific calculator, you can use the mathematical methods or Excel sheet, very, very friendly tool. But the problem is, in the net present value, the net present value failed to compare between different projects with different size. And we will talk about this problem. So if we have two different firms and suggested two different size of investments, so the net present value failed to address this problem. So this is why the financial analyst or the financial scientist they provide us with another tool which is known the equivalent annual cost. Equivalent annual cost instead of using the net present value. We will talk about the equivalent annual cost, and some other people use in replace with the net present value, they use the profitability index. The profitability index is similar to the net present value, and we will talk about the difference between the net present value and the profitability index. And other financial people, they use the IRR, internal rate of return. The internal rate of return is when the cash inflow is equal to the cash outflow. So in this case, when the net present value is equal to 0, we are locating what is the rates of return that make the cash inflow equal the cash outflow. Then I will talk in detail about the IRR. And at the end, I will talk about the payback periods. Okay, so I will focus now on the net present value. How we calculate the net present value? It is very simple. Just go back to the streamline. If we have here the initial cash flow, the initial investments, you starting your investment, for instance, by $100,000 or $50,000, it's considered as the initial investment. Then the cash inflow is coming after a particular period of time, let's say in year 1, year 2, 3, 4, and 5. So in year 1, you have cash flow 1, cash flow 2, cash flow 3, cash flow 4, and cash flow M. So considering that, the cost of capital or the interest rates of this company is say 10%. K or R or I is 10%. Some people, they get confused on understanding what it means, the cost of capital. Just to remind you what I've said in 2 chapters ago, I told you that this is the T statement. This is the balance sheet. So we have here assets and we have liabilities. Okay. So in here we have current assets and we have fixed assets, and here we have current liabilities and long-term debts and equity. Now, what it means, the cost of capital, it means how much it costs us as a percentage to fund this area, or to get fund from the long-term debts and from the equity. This handle in chapter, I think, 17. Fortunately, we don't have time to talk about chapter 17. So when you grow up for 1 year or 2 years, we will talk about this in the future, inshallah. Okay? So, yes, cost of capital. But in the net present value, I will give it to you. So don't worry about this. You don't need to go for understanding or studying chapter 17. Okay? So just, this is 10%. But why I talk about this? Because it is fine to understand where the 10% coming from. Because sometimes I ask you to estimate this, but not in your level, in the MBA level or in the advanced financial management in the bachelor degree. Okay, so this is the idea of the cash flow. Now, we want to calculate the net present value. So the net present value, as we explain or we define, is the discounted cash outflow minus the discounted cash inflow. So we have this, so minus the cash flow, okay, plus the cash inflow, 1 plus k raised to the power 1, and blah blah blah, then cash flow n divided 1 plus k raised to the power n. Now, how we judge on the results? If the result is positive, so the project is accepted. Otherwise, is not accepted or rejected. So otherwise includes 0 and minus or negative. So is not accepted or rejected. Okay? So I think you understand now what it means, the net present value. Okay, we will go about the example of yeah, it's fine. I mentioned for this problem. Sometimes the problem of the net present value, in addition, is not comparing between the two different sizes if the projects depend on each other. We counter problem. For instance, if we have the project A and B is dependent on A. For instance, we have machine. We want to replace the machine. We compare between old machine and the new machine. Or after a period of time, we want to replace the old machines. If we have 3 projects, and one of these 3 projects depends on the other projects. So we will counter the problem, and net present value no longer work in this. So what is the solution? We can apply the equivalent annual cost. So net present value is fine in the independent investment project. So the independent investment project is one that stands alone and can be undertaken without influencing the acceptance or rejection of any other projects. So we can apply the net present value. A mutually exclusive project, so we have some projects depend on each other, prevents another project from being accepted. Okay? So the decision is, it will require 2 steps. The first, calculate the net present value, then accept the project if net present value is positive and reject if it is negative. If I go to the net present value. So as we mentioned in here, we discounted the cash flow, the cash inflow and cash outflow. Then if it is positive, it is accepted. If it is negative, it is not accepted. Take this example here. I recommend you to use the streamline. It is very simple, and you can easily apply this. Project Long, the name of project is Long, requires an initial investment of $100,000. Sometimes my student asks me what it means, initial investments. Yes, initial investment, not only the cash outflow, is when we are starting the business. The starting a business includes the initial investment, which is the big investment that we start the big money that we start our investment. Is not only the cash outflow, because if you considering that the initial investment is the cash outflow, take this example. If we have here minus $10,000 and we have here $10,000 as cash inflow and here minus $5,000, do you consider this is initial investment? No, it is not initial investment. The initial investment is coming at the starting point of the investment. Okay? It is cash outflow, but is important to start up your business. Okay? So this is the meaning of the initial investment, because sometimes the student asking, what is the cost? They consider the $100,000 is a cash inflow. So it is not cash inflow, it is cash outflow. So the first one here, by using the streamline, Project Long requires an initial investment of $100,000. So here from zero, $100,000. Don't forget this is cash outflow. And is expected to generate a cash flow of $70,000 in year one. So you have in year one here, $70,000. $30,000 per year in years 2 and 3. So we have in year 2 and year 3, 30 and 30. Okay, and $25,000 in year 4. So $25,000, and in the year 5 is $10,000. Fine. So we have 5 years. We have the initial investment in here. We have 70, 30, 30, 25, and 10,000. Okay? So the discount rate K, so what is K here, is the cost of capital. So the discount rate K, appropriate for calculating the net present value of the Project Long, is 17%. So K here is 17%. When you are handling your question, please do it in this way. Why? Because it's reflecting that you understand what is the figures in your question. This is the first step in handling your answers or your question properly. Now we want to know whether the project is a good for investment or not. We apply the equation. So then the net present value is equal minus 100,000 plus 70 divided 1 plus 0.17 raised to the power 1, then 31.17. We know now 17 is coming from then 31.17 raised to power 3 plus plus 1.17 raised to the power 4, and the last one is 1.17 raised to the power 5. Don't forget that's just we have 100 here. 100,000 it means 170, 30. Okay, now you discounted this. Okay? 3020. So 1832. 183 78. Okay, so 78. So it is 18,378. It means positive, so is accepted. Okay? Any question there? No question. Okay, so you see the answer as you hear, 18,378. Okay. This is another example here. We will see this example again. Saber Electronics provides specialty manufacturing services to defense contractors located in Seattle. The initial outlay is $3 million. So what is this initial outlay? What is? This is initial investment. Okay, right. So it is 3 million. Okay, so you have this is streamline, and you have 3 million. Some students face problems in using calculators in terms of big numbers. I don't mind to use the abbreviations or to rounding. 3 million, I know it costs you time to put the 3 million. You don't need even to use this. Just remove the 3 million and do it. Okay? Just a 3. Okay? So don't confuse from the big numbers. Okay, so now to defend Seattle, the initial outlay is 3 million, and management estimate that the firm might generate cash flows for years 1 through 5 equal to 500s. So this consider this is 3,000 or 3 million. Then how many years? The initial outlay 3, and management estimate the firm will generate cash for years 1 through 5. So we have 5 years 1, 2, 3, 4, and 5. In the year 1,
500,000.
so we have 500. In year 2, we have 750. In year 3, we have 1,500. In year 200, 2 million. And 2 million. Okay? So Saber uses 20% discount rate. So we have K is 20%. Okay? Then is this project a good investment or not? Again, the net present value is equal minus 3,000 plus 501 plus 20% raised to the power n plus 750 1.20 raised to the power 2 1,500 1.20 raised to the power 3 plus 2,000 divided 1.20 raised to the power 4, and the last one 2,000 1.20 raised to the power 5. So what is the result? Sorry? 5? Say it again, please.
573.
573.
817.
800. Okay, anyway, this is we'll see the results. Okay, so the results, okay, is accepted then. Okay, you can look at here how the slide using the abbreviations or rounding. So please, if you have big figures or big numbers, don't get confused. Okay, sometimes I intentionally do this. Yeah, because see how people they use the calculations. Okay, so this is the result. So it is accepted because it is positive. Okay, any question? No? Yes? Okay, so this is good news. Now, evaluating mutually exclusive investment opportunities. We will ask ourselves, if the net present value if we have only one project, so the net present value is fine. We can apply the net present value. We don't have problems in the net present value if we are subject with only one project. Otherwise, we will think to use the equivalent annual cost or IRR or other tools. There are times when a firm must choose the best project or set of projects from the set of positive net present value investments. These are considered mutually exclusive opportunities, as the firm cannot undertake all positive net present value projects. For instance, if we have A, B, C, and D, and all of them are positive, we cannot apply, because we have limited funds, we cannot apply all of the positive net present value. So what is the solution then? We can apply the equivalence, we can apply the, let's say, the interest rate of return, we can apply MIRR. It's not necessarily only to be limited with net present value. Okay? Let's see the case here. Following are two situations where firm is faced with mutually exclusive projects. The first one, substitutes, where firm is trying to pick between alternatives that perform the same function. Okay? For instance, we have two different alternatives to replace the machine. For example, a new machine for the new projects. While there might be many good machines, we have many machines, and just to estimate, the firm needs only one. We go to the shops and ask how much this machine and how much this. We have 5 alternatives. So how we can compare between the 5 alternatives with different lifespan, with different initial investments. So the net present value is no longer benefits in estimate this. Okay? Take this example here. Okay, so we want to replace machine A with B, C, or D. Okay, B, C, and D. The initial investment of B is $10,000, and this is $5,000, and this is, say, $15,000. So the problem is we have different initial investments. Okay, considering another problem, so the one with $10,000, the lifespan is 2 years. But here is 4 years, and here is only 1 year. So we cannot apply the net present value because it will confuse or give a confusion results. What is the solution then? The solution is to apply the equivalent. Okay? Okay. 2 firm constraints. Firm may face constraints such as limited managerial time or limited financial capital. As I told you, we have only $20,000 or we have only $7,000. So we limited ourselves just only by one alternative. This case, and then we cannot apply the net present value. Okay, so choose between mutually exclusive investments. If mutually exclusive investments have equal life, we will calculate the net present values and choose the one with the higher net present value. But if we have equal lifespan, okay, all of them are 4 years, all of them 5 years, okay, so then we apply the, it doesn't matter what is the initial investment. Because very simple, the one with the lower initial investment is more acceptable than the one with higher initial investments. Okay, so we standardized the lifespan. If we standardize the initial investment, then we are subject to different lifespan. Then we will apply the equivalent annual cost. If mutually exclusive investments do not have equal life, we must calculate the equivalent annual cost. The cost per year, we will then select the one that has a lower equivalent annual cost. It is this annual or equivalent annual cost is similar to net present value, but just do little changes in the calculation. See, the first one, compute the net present value. Already the net present value is included in the calculations. Then we apply compute the equivalent annual cost as shown in the equation 11.2. So equivalent annual cost is the present value of cost divided by the discounted rates. Okay? So this is the, and to estimate this, we will go back to the present value annuity. Just remember the one in chapter 6. So if you don't know about chapter 6, okay, try to revise this chapter and to know how we calculate the annuity. This is annuity. So the first thing, we calculate the present value of the cost, then divided by the annuity of the present value. You can apply the table, and you can apply the equation as shown in chapter 6. Wow, it's big. Okay, so to summarize this, okay, to summarize this 1,000 words, okay, this is the streamline is summarizing what in this table. This company wants to replace bottling machine, the new one with the old one with the new one, and they have two alternatives: one cheap and one expensive. We will see. We have project long 5 years, and we have project short 3 years. So we have two alternatives: one with 5 years and one with 3 years. The one with 5 years, it costs, the initial investment is 30,000. The one with 3 years, the initial investment is 20,000. And this is the cash outflow. This is for maintenance. And this is the cash outflow for maintenance. Okay? Now, if you look at the two, before answering the question or calculate the equivalent annual cost, look at this. So if you have this data, which one you will select? The one with the $30,000 or the one with $22,000? Yes, $22,000. We do not. Yes, but consider that this is the problem. What I said if we have similar initial investments with different lifespan, so it's very simple. We can select the shorter. But in this case, we have different lifespan. So what we think, it's very difficult to say this or this. Okay, so we have to calculate the equivalent annual cost. The first step is to calculate the present value. And the present value is being discussed in chapter 6. Just go back to chapter 6. So very simple. What we can do then here, 30,000. So this is the as in the streamline. In the streamline is we have 30,000, okay, and we have 3 for how many years? For 5 years. So just discount this. 1 plus k raised to the power 1, 1 plus k raised to the power 2, 1 plus k raised to the power 3, and this is the same 1 plus k raised to the power 5. Then add up to the 30,000, you have the present value. Then divide the present value by the present value annuity factor. Present value annuity factor. Okay, so you have these two streamlines. Okay, see the answer. So 30,000 as in the this 3,000 divided 1 plus k raised to the power 1, raised to the power 2, 4, and 5. So we have 41,000. Yes. And we do the same for the second project. We have 32,000. But still, if we compare this, still we can apply the second project. But if we discounted them, the result will change. Okay. Now, the equivalent. So the present value, which is 41,000, divided by the present value annuity. This one. Well, if the present value annuity 8%, calculate the 8% for 5 years annuity. So 8% for 5 years annuity is equal 3.9927. The result is minus 10,000, and the result of the second project is minus 12,000. So then, which one is accepted? The first one, because it's cheaper than the second one. Because here I have to pay 10,000 year annual, and this is. What is the concept behind equivalent annual? What is the concept? Let's go back to see what it means 10,514. Go back to this. What I want to do is to try to equalize the lifespan of this. I want this one to be 5 years and this 5 years, or this 3 and this 3. So I want to equalize the cash flow. We have $30,000 here and 3,000. I'm asking myself, what is the annual cash flow that I have to pay for this for 5 years? And I ask the same question, what is the annual cash flow that I have to pay for 5 years in this one? Then I will compare between the two similar lifespan. So this is what I've done in this example. It means here the annual cash flow is 10,000, and here the annual cash flow is 12,000. In this case, this is the cheaper. Okay, take another example here. Yes, we have just 5 minutes. Okay, you can do this example. Just to explain to you this example, and you can do it by yourself. In this example, what is the equivalent annual cost for a machine that costs $50,000, require payments of $6,000 per year for maintenance and operation expenses, and lasts for 6 years? So we have the streamline for 6 years here, and the initial investment is $50,000. Okay, so. And the K is 9%. In addition, you intend to replace this machine at the end of its life with an identical machine with identical cost. So now, what is the equivalent investment, or what is the equivalent annual cost? Just try to apply this equation. You will have 56 million or 6,000. And the answer is 76,000. So try to do it by yourself, okay? And you will get the answer. In next meeting, I will talk about the other investment criteria. Okay? Any question? يعطيكم العافية.